The first one, we need to break each force to 3 components. One in X, one in Y, one in Z. We have 3 situations. You can figure out which one or which technique I'm gonna use to break the force to 3 components. Sometimes we have alpha, beta, gamma. Sometimes we have 2 points with coordinate. Sometimes we have a projection line. So we have sine, or sine, cosine, or cosine, sine, or whatever. Once you break each force to 3 components, then I can add all X components together. I can add all Y components together. I can add all of the components together. We have 2 situations here. If you are talking about forces in 3D and we are looking for a resultant like last week, that means summation of all X components equal X component for the resultant force. Summation of all Y components equal Y components of the resultant force. Summation of all forces in Z direction equal Z component of the resultant force. If you have resultant. If resultant is given, so something is missed in this side because Rx is given. Or if we are looking for resultant, then this side will be known. The only unknown will be the X component for the resultant. This is the first scenario. The second scenario, this week, we have forces in equilibrium. If the forces are in equilibrium, that means the resultant force equals 0. So summation of all X components equals 0. Summation of all Y components equals 0. Summation of all Z component equals 0. That's it. But remember, the first step you have to remember all the time, and you have to train yourself how to break each force to 3 components. Once you did this step, then we have 2 scenarios. This one, if we have resultant force, or this one, if this force is in equilibrium. Until this moment, anybody has any question? Any question for this point? The key this week or last week for forces in 3D, how to break each force to 3 components. We have 3 scenarios. We have 3 situations. Please go back to these and train yourself how to use them. Okay. We covered first example last meeting. Let's do this example. We have a balloon. This balloon is subjected to net uplift force F equal 800 Newton. We have a force here F, uplift force equal 800 Newton. My question is, before continue, if I'm looking for F as a vector, what will be this vector? As you see from this diagram, or uplift force means upward, vertical force to upward. So this force as a vector will be 0 in X, 0 in Y, and the positive 800 in Z. This is the first information. This balloon is connected to the ground by rods AB and AC and AD. We are looking for determining the tension forces developed in these ropes. Okay, by the way, we have three axes. The first one is x-axis. Here is the positive direction of x. Here is the positive direction of y. Here is the positive direction of z. Okay. I think we don't have any angles. I think we don't have alpha, beta, gamma. I think we don't have any projection line. I think we can figure out the coordinates of this point. Can you help me? What is or what are the coordinates of point A? Where is point A? Here you go. Remember, this origin is 0, 0, 0. If you are going from this origin to point A, I will move in x0. I will move in y0. I will move in z 6 meters. What about point B? What are the coordinates of point B? Where is point B? Here you go. This one. If you would like to move from the origin to point B, I'm walking in x negative 1.5. I will move in y negative 2. I will not move any in z direction, 0. Keep going. Point C. What are the coordinates of point C? Here is point C. If you would like to move from the origin 0, 0, 0 to point C, I'm gonna move in x, how much? 2, positive 2. I'm gonna move in y, negative 3. I will not move any in Z. What about point D? Point D, here is point D. In X, I will not move any. In Y, I will move 2.5. In Z, I will not move any. So first step, I will search for the coordinates of point A, B, C, and D. So we need to figure out where is x-axis, where is y-axis, where is z-axis, where is the origin, and then we can figure out the coordinates of these points. Any questions so far? Any questions so far? Okay, so I am done with with the first force F. We have a force AB. We have a force AB. So how can I convert or I get force FAB as a vector? Force AB as a vector will equal force AB as a value. I'm talking about force AB, this direction. So the first point will be A, the second point will be B. Do you remember? Do you remember? Coordinates of the second point minus coordinate of the first point. So B minus A. B minus A. Minus 1.5 minus 0 will be minus 1.5i. Minus 2 minus 0 will be minus 2j. 0 minus 6 will be negative 6k. Divide square root for this one, for this value square, this value square, this value square. I don't care about the sign positive or negative because the square doesn't care positive or negative. So the final format will be something like this. FAB This one negative 1.5i, negative 2j, negative 6k, divide, what is the value of this number? 1.5 square plus 2 square plus 6 square, all of them under square root. It will be 6.5. To simplify this one, so 1.5 divide 6.5 will be negative 0.23 FAB I. Negative 2 divide 6.5 will be 0.307 FAB J, negative 0.923 FAB K. I am done with the first force. I am done with the first force in the ROB AB. I converted this force to a vector, so I can figure out the X component, Y component, and Z component for this force. Any question, guys? Keep going. The second force, I'm gonna figure out the component for AC. So for AC, if AC as a vector equal FAC, remember, coordinates of point C minus coordinates of point A. AC. So A is the first point, C is the second point. So AC. So we have positive 2 minus 0. We have negative 3 minus 0. We have 0 minus 6. So we have 2i, negative 3j, negative 6k. That's right. 2, negative 3, negative 6. Yes. Divide square root of these numbers square. I can simplify. So FAC time 2i minus 3j minus 6k divide 4 plus 9 plus 36 under square root, it will be 7. If you would like to simplify it more, so we have 2 divide 7. It will be positive 0.285 FAC I, negative 3 divide 7 will be 0.428 FAC J, negative 6 divide 7 will be 0.857 FAC K. I am done with the second force. FAC, I can figure out the X component, Y component, and Z component. What else? The third, there is a force FAC. The third force will be FAD. So I will talk about force AD. FAD as a vector equal FAD time AD. So coordinates of point D minus coordinates of point A. These coordinates minus A. 0 minus 0 is 0. 2.5 minus 0, 2.5. 0 minus 6, minus 6. So we have 0, I, positive 2.5, J, positive 6, I'm sorry, negative 6K. One more time. 0 minus 0, 0. 2.5 minus 0, 2.5. 0 minus 6, minus 6. That's right. Divide square root of this number square. 0 square, 2.5 square, 6 square. More simplification. 0i, 2.5j, negative 6k, divide 2.5 square plus 36 under square root. This one will be 6.5. So your final answer will be 0i plus 2.5 divide 6.5 will be 0.38 FAD J, negative 6 divided 6.5 will be 0.923 FADK. So finally, I got the components, the X component, Y component, and Z component for force FAD. So we have FAD, we have FAC, and we have FAB, and we have a force which is given F. Okay? These forces, all of these forces, F and the FAB and the FAC and the FAD, all of these forces are in equilibrium. What does it mean? Means if you add X components together, all of them equal 0. This one plus this one plus this one plus this one equals 0. So summation forces are in equilibrium. That means summation of all X components equals 0. So the first component is 0. The second component for the second force, 0.23 FAB, negative. So 0, negative 0.23 FAB, negative. What else? Third force, we have positive 0.285 FAC. The third force, FAD, we have 0. X component plus X component plus X component plus X components, all of them equal 0. Equation number 1. Summation of all Y components equals 0. Go back to the first force. Please don't forget any force. Y component 0. Y component here negative 307. So we have 0, negative 0.307 FAB. We have in the third force here negative 428 FAC. The last one we have positive 38 FAD. So Y component plus Y component plus Y component plus Y component, all of them equal 0. Equation number 2. Summation of all Z components equals 0. We have here in Z direction positive 800. In Z direction we have negative 923. So we have 800. We have positive. Is it positive or negative? It's negative. 0.923 FAB. What else? For this force, we have negative 857 FAC. What else? For this one, we have negative 923 FAD equals 0. Third equation. I added Z component plus Z component plus Z component plus Z components equals 0 because these forces are in equilibrium. Finally, we have three unknowns, FAB, FAC, FAD. We have three unknowns. And also we have three equations. Equation number 3, equation number 2, equation number 1. I can figure out these unknowns. I suggest to use a calculator to solve these equations together. I will do it right now. FAC, my calculator can do it. I highly recommend to learn how to solve these equations together by your calculator. Let's try. I'm gonna try. What is equation number 1? So we have 0. We have negative 0.23. We have positive 0.285. Equals 0. Second equation, we have negative 0.307. We have negative 0.428. We have positive 38 equals 0. This one, we have negative 0.923. We have negative 0.857. We have negative 0.923 equal negative 800. So FAB will be 255.6. This one will be negative. 646.7 or 0.6. This one will be 521.9 Newton. During the exam or the homework, if you set up these equations correctly, equation number 1, number 2, and number 3, and you don't have a chance to get the final answer, that's fine. You will not lose any points, promise. But set up these equations correctly. If you set up these equations correctly and you don't have a chance to solve for the final answer, that's fine. Any question? I am confused with how you are solving. For me, I started to learn how to solve this equation probably 1 year ago. This is the first time for me to use my calculator because I have advanced calculator. So my suggestion for you, Mitchell, to go to Google and search using the model of your calculator, or YouTube, how to use this model of calculator to solve system of equation. They will let you know, because every model has different way. Each model of calculators has a different way to be used in solving this equation. Okay. Let me repeat what I did one more time with this example. We have another example. We have crate, we have box, we have weight. How much? 300. The weight of this box or crate equal 300 pounds. As you remember, weight means vertically downward. And this box is supported at point A with another 3 ropes, AB, AC, and AD. We are looking to determine what are the forces developed in these cables, AB, AC, and AD. The same concept. As you watch in this problem, we don't have any angles, alpha, beta, gamma, or we don't have any projection line with angles. So the only way to figure out the coordinates of these points. First step, please put your hand on the axis. We have here x-axis, we have here y-axis, and we have here z-axis. Then, where is the origin? Point A is the origin, 0, 0, 0. So point A is your origin, 0, 0, and 0. What about point B? Where is point B? Here you go. This point. How can I move from the origin to point B? I have to go in x direction by -2. I have to go in y direction, how much? +1. I have to go in z direction, how much? +2. Second point, point C. Where is point C? Here you go. I would like to move in x direction, how much? -2. In y direction, how much? -2. In z direction, how much? +1. Point D. Here is point D. In x direction, +3. In y direction, 0. In z direction, 0. We have only 3 in x direction for this point, point D. Nothing else. We have 4 forces. We have a force due to weight. We have a force AB. We have a force AC. We have a force AD. Anybody can tell me what is the vector for the weight? This box has a weight equal 300 vertically downward. So how can I get or convert this force or this weight to a vector? It's very simple. This weight in z direction only. So we don't have x component. We don't have y component. We have -300 in z component. This is the first one. What else? What do you have else? Let's start the same story for AB. I assumed it to be AB like this. So if AB as a vector equal FAB as a value time. I said AB. So coordinates of point B minus coordinates of point A. -2 minus 0, or -2 minus 0, +1 minus 0, +2 minus 0 will be -2i, +1j, +2k. Divide first one square, second one square, third one square. I'm sorry, this one is 2 square. You can simplify these terms, will be 4 plus 1 plus 4 underscore 2. So equal FAB time, this one will be -2/3 I, +1/3 j, +2/3 k. This term will be 3. Keep going. Next one, I'm gonna talk about AC. So I'm done here. Second. For AC, FAC as a vector equal FAC as a value, and I said AC. So point C minus point A. What do you have here? Point C minus point A. So -2 minus 0, -2 minus 0, +1 minus 0 for point B. I'm sorry, for point C. Okay, so it will be -2I, -2J, I think, +1, yes, +1K, divide 2 square plus 2 square plus 1 square. Your final answer will be FAC time -2/3 I, -2/3 J, +1/3 K. This term will be 3. What else? The coming force for AD. Force AD as a vector equal FAD as a value. AD. So point D minus point A. Point D minus point A will be 3 minus 0, 0 minus 0, 0 minus 0 will be 3I, 0J, 0K, divide 3 square plus 0 square plus 0 square. Your final answer will be FAD time 1I, 0J, 0K. Do you have any more forces? No, I am done. We have only 4 forces. Weight, AB, AC, and AD. All of these system of forces, all of these stuff are in equilibrium. So, for equilibrium, summation of all x components equals 0. Go ahead and put these components together. X component here 0. X component here 2/3, negative 2/3. So we have 0, negative 2/3 FAB. What else? What do you have here? Negative 2/3 FAC. What else? We have here +1 FAD equals 0. First equation. Second one, summation of all y components equals 0. One by one, please don't forget any. Be organized. Y component is 0. Y component 1/3. So 0 plus 1/3 FAB. Y component here negative 2/3 FAC. Y component here is 0 equal 0. Second equation. Summation of all z components equals 0. One by one. Do you have z component here? Yes, negative 300. 2/3 positive. So negative 300, positive 2/3 FAB. What else? For the other forces, we have here z component positive 1/3 FAC, We have zero component here, I think. Zero component for Z equals 0. Third equation. Solve equation 1 and equation 2 and equation 3 together. I can figure out the value of FAB, the value of FAC, the value of FAD. As I told you, I promise you, if you set up these equations correctly, I will not deduct any points for the final answer. That's enough for me, because all of these stuff are math calculation. But pay attention to break your forces in 3 components. Be careful. The key in this problem is how to figure out the coordinates of the points. Because if these coordinates are wrong, everything will be wrong. These coordinates are very important. You need to keep taking these points before breaking your force. So please pay attention to these points before continue. What determine point A? Because last time it wasn't on the origin. Okay. At point A, all forces connected. We are talking, Mitchell, we are talking about concurrent forces. Concurrent means all of them intersect at one point. So all of them here are intersects at point A. Previous example, all of forces, can you watch? All of forces are connected at point A. Here is point A. We have the uplift force, we have this force, we have this force, we have this force. All of them intersect at point A. So here is the particle in equilibrium. Whatever point A at origin or not at origin, I don't care. I don't care. I need to figure out the equilibrium of point A. Why point A especially? Why not point O? Because all of your forces intersect at point A. And here is point A. In the second example, all of your forces, all of rocks, all of weight, everything connected at point A. You are lucky because point A is the same like the origin. So it's luck only. So I don't care. Point A is the intersection of all forces. Okay? Okay, thank you for your question. It's a good question. One more. We have system of forces. Guys, this one looks like your quiz. I'm not sure why students confused about this one. We have forces given 225, this one. We have a force here 150, this one. We have 3 more forces. The first one called F1 is unknown in this situation, in this problem. We have another force F2 is unknown. We have a third force F3 is unknown. So my question is, how many forces do you have here? We have 5. We have 5 forces. 2 of them not labeled. 2 of them are not labeled. I can label them F4 and F5. What is the problem? No problem. We have 5 forces. These forces intersect at this point. But I think in this case or this problem, we will not use coordinates because we can use alpha, beta, gamma, projection line, all of this stuff. I think we are in this case. Let's start force by force. Let's start with F1. F1 as a vector I believe F1 we have 3 angles, alpha, beta, gamma for this force. So F1 as a vector equal F1 cosine, how much? 60 I, F1 cosine 60 J, F1 cosine 120 K. I am done with F1. What about F2? F2 as a vector, no need for anything because F2 is very simple. F2 in the same direction like Z axis. So we have 0 I, 0 J, and the positive F2 K. What about F3? What's going on with F3? Where is F3? Here you go. F3 in the same direction of negative direction of y-axis. You agree? This is the positive direction of y. Guys, here is the positive direction of x, positive direction of y, positive direction of z. Anything else will be negative direction. So we have 0i, negative f3j, 0k. What else? Keep going. For F4, what do you have in F4? F4 is a force 225 in the negative direction of x-axis. So we have negative 225 I, 0j, and 0k. Keep going. We still have one more. What about F5 as a vector? Hey, F5, we have a line, projection line. Do you remember? If you cannot figure out how can we use the projection line, please pay attention. I'm talking about F5, this one, equal 150. This force has a line here called projection line. This line called projection line. First step, we need to break this force between the projection line and the z-axis. Using this angle, 45 degrees, between the force and the projection line. I think the projection line is adjacent to 45, so this component will be 150 cosine 45. That means the z component will be 150 sine 45. This is the first step. Second step, we need to break the projection line between x-axis and y-axis using another angle here called 30 between the projection line and x-axis. Which one will be cosine? Which will be sine? Your x adjacent to 30. So this one will be cosine 30. What is the cosine 30? This value. So 150 cosine 45 will multiply by cosine 30. What about the y? Will be 150 cosine 45. Here is the value time sine 30. So finally, F5 as a vector will be positive 150 cosine 45 cosine 30 I. For y component, this direction is negative. So negative 150 cosine 45 sine 30 j. What about z? Positive 150 sine 45 k. Do you have any more forces? No, I'm done with all of them. F1, F2, F3, F4, F5. All of them. These forces are in equilibrium. What does it mean? Means x component plus x component plus x component plus x component plus x components equals 0. What else? Y component plus y component plus y component plus y component plus y component equals 0. What else? Z component plus Z component plus Z component plus Z component plus Z components equals 0. We have 3 equations. We have 3 unknowns. I can figure out these unknowns. So guys, the only key in any problem in 3D, first step, you have to break each force to 3 components. Once you are done, your problem 80% or 70% is done.